here soon. Wait for it to the nice lady to say the thing.
I'm going to mute myself.
Okay, cool. So just quick preamble for me. Yeah, try to maintain good muting if you can. If not, I'll mute people that give feedback and such as needed. Yeah, John, feel free to take it away.
Okay, hey, first off, I'd really like to thank you, Meg, Linda Larkey, and Nick O'Neill for making this possible. To be able to share some of my knowledge with other kite people. I guess I'll start off by saying my name is Jon Trennepohl. I've been in doing things in kites since 1987. Unlike a lot of people that are hobbyists, I actually decided to make kites my livelihood. So after 32 years, I've been running a kite store called Kites and Fun Things. I also manufacture Skyshark tubes. I do quite a bit. I'm a consultant for Premier Kites. I do a lot of design work as well. But I also, I guess the biggest thing with me is through all of my kiting career is dealing with structural stuff involved with manufacturing kites. And not only kites, but a lot of remote control airplanes, helicopters, a lot of remote control sailboat things like that. A lot of anything to do with structure, which then moves into fiberglass. You know, in the old days, you know, when we first started, there was a lot of things going on with wood products that were in kites. We still see a little bit of it. I'm always fascinated by what I see in the way of bamboo. Okay. And some of the other things from other countries that I've seen. And, you know, usually you're using any available constructive materials for building and framing kites by what's around you or what's available. So I think we're lucky here in the States that as time's gone on and technology has come forth, that we have a lot of really interesting products when it comes to building kites. I guess, man, I could start off, you know, like, as far as wood products go, I mean, they're still being used. I've got some, you know, I mean, bamboo is still used. I know that Glenn, I've got some of the little miniature kites. You usually probably use a lot of wood in construction with some of your lighter little kites. I know that the Chinese are still creating a lot of kites. Hold on just a minute. That are still using, and fighter kites in India also are using a lot of fighter kites. Also, a lot of the kites from China that are like this with construction in the back that's quite dainty with wood stuff. I mean, we still have, you know, replaced dowels every once in a while in the store, but I got to say that they're far and few between these days. You know, usually we're dealing with less expensive things, and depending on your application, fiberglass, which is a extruded, pultruded type arrangement, and there's different kinds of glass, whether it be solid, and that's another thing people always, you know, they refer to a lot of the sticks for kites as being, you know, they call them tubes or rods. Rods are solid. You know, tubes are hollow, so that's a big one, you know, and really a lot of the building techniques has to do with the size of the fiberglass rods from down to being very small, which we call micro, and in carbon, which is microcarbon. That's, you know, and then I guess it's determining what you're going to be building. And I've got lots of applications here. I get questions all the time about, you know, what's best for building certain things, okay? I can give you a little bit of background if there's an interest in how some of the tubes, you know, we've got, most of the fiberglass is a extruded product that's pulled, you know, through filament wound stuff, and it has, you know, it's a continuously pulled product. So I've actually been in China and watched them actually pull fiberglass where it's actually coming through the epoxy, the threads are coming through the bath, It'll go through the head that determines the inside or outside diameter, goes up to the ceiling, and there's a guy 50 feet away that's actually cutting lengths, and it just continually pulls until they run out of material. It's quite interesting. And Pultruded Carbon is actually done a lot in the same fashion, except they do it in shorter lengths and then cut it to lengths so that when we buy it, we determine what length we're going to use for our kites and then cut it. And then it's, I guess, the application of what you're building and the deflection of the tubes. So I have a lot of examples. I think that I could go over, I guess, the different products that are available and then how to use them. That's what I was going to try to cover today. So basically, we're looking at fiberglass, which is actually, you know, is a pulled material. And the comparison, you know, to when you're using the fiberglass is that it actually is going to have a, you know, a softer deflection than carbon always. And when you're using the fiberglass, depending on a lot of the sizes, which usually get down to basically, you know, we don't find too much 1/8" tube anymore. Most of the time it jumps into 4 millimeter, 5 millimeter, and goes on up to some pretty big diameters. But most of the time when we're using tube anyway with fiberglass when we're building, you know, I have a lot of people always wanting to know how that you ferrule it or connect it to another tube, which is really important because most of the time, you know, with fiberglass, there are some fiberglasses that can be internally ferruled, which are a lot of the older tubes were glass forms, which were actually they were a continuous filament wound type fiberglass. We used to see a lot of those in the earlier days, and that kind of a fiberglass has actually got more of a wound, and it's a stronger because of the way that they make the fiberglass. You could actually internally ferrule it, and but as then most of the pultruded ones, they're still pretty strong and can be used for ferrules for other things for the inside. But as far as most of the time with connecting them, we're using connectors that actually will go over the tubes and are called external. And they're usually made out of either another fiberglass or a bigger diameter tube that goes over so that you can join one from one side to the other. And there's ways of also making these stronger. It depends on the force that's on the tubes when you're connecting and putting them together, where they need to be. You can actually use different materials to actually plug the end of them and glue them inside, which then in turn makes the tube stronger on the inside diameter. So you could use on this was an 8 millimeter tube, and it depends on the inside diameter. You could actually put a plug in this at a certain length on each side when you join it, which will increase the strength of the tube. So, you know, the big difference between the fiberglass is it depends on what you're building and how much deflection that you need, you know, on the tubes. Like in comparison to an 8 millimeter piece of fiberglass compared to then to a carbon fiber tube, the difference in deflection is it's a lot stronger in relationship to the fiberglass. But it depends on what you're building and whether or not you want something softer. Every design on a kite, you know, depending on, especially if you're doing something yourself, can be changed, you know, by going up in diameter. As the diameter increases, of course, the weight goes up and the strength of the tube goes up. In most cases, that's the way that it works. And then it's like, you know, and then you're determining wind range as well. And it goes the same when you're doing tubes. You know, you can use a lot of, on smaller stuff, you can use the fiberglass, which will take a full radius, like on an 098 tube, and you can almost bend it without anything breaking. Now, if you do the same thing with a piece of carbon, it can splinter. So it really depends on you know, the deflection of what you're trying to build. And as the microcarbon gets down into smaller sizes, you know, they can become very dainty and lightweight. And the construction of some of those kites, and I know you've seen a lot of the iFlight stuff. Well, this is incredible, that the amount of microcarbon and how it's done with this kind of a kite. I mean, I think he's using down to like 3.0 carbon and up to like maybe 4.0, 5.0, but it can, you know, create things that are very light with materials. So it's a lot on the microcarbon and stuff on what you're building, and you know, what, just the fabrication of how you create whatever kind of kite you're going to do and apply the carbon or the size of it in how much it bends and the weight distribution of the kite you're trying to make. So there's a lot of different ways to determine that. And a lot of it's just trial and error. I have always, you know, people calling me trying to say, well, I'm building this, what's the best thing to use in it? That's a tough. There's a lot of trial and error unless you've had somebody and you're copying somebody that's already done it and you know specifically what that is. So, and the micro, you know, the microcarbon, you know, comes in some various sizes. From, they stopped making 2.0, I think, or 10 to 2.0, but you still can buy 3.0, 4.0, 5.0, and all the way up. Now the fiberglass products in micro on the micro solid rod is a lot harder to find. We carry a lot of we don't, it's very, every once in a while we'll get 5.0 fiberglass in rod in it, but you know, like 6.0, 7.0, 8.0, and all the way up, you know, into usually some pretty good sizes, you know, into 5-6 millimeter we use, but most of the time it's smaller than that. Most of the time then you jump to a tube, which is stiffer. But you can always, like if you're doing standoffs on something or you have to bend something, usually if you're using a piece of like, say, 8.0 carbon, if you want the same kind of bend, you have to go up to probably a 3 millimeter fiberglass to get the same kind of a structural bend or deflection. That's the way that works. What else? So mostly, you know, when we're working with, and then when you move into the pultruded carbon, the other thing with the pultruded carbon is that you're always using, most of the time it will split, unlike fiberglass, easier. So we're using, you know, external ferrules on almost all of the fiberglass. And if you want to reinforce and make them stronger, then you're always using, you know, a plug that usually goes inside that's glued with, you know, usually CA or an epoxy, and it strengthens each. I make some big kites called pointers, and I use a lot of 10 millimeter because the kite's like got a 22, you know, spine, 22-foot spine going down the middle of it, and at each one of the joints are one of our wrap carbon tubes, which is a P400, goes right inside of the 10 millimeter, and I can use like an 8 or 10 inch piece of it at each joint glued in, which really makes the whole overall deflection of a spine that's 20 feet bearable for the type of construction that you're doing. So that's you know, really important. And then the other one too is always like rounding. When you're using and connecting these things, it's always a good idea to sand the outside beveled edges on a lot of these, which takes more stress off of the pressure on the tubes when they're inserted in each one too, and it keeps them from splintering as well. What else? Let's see, was I going to talk about? And then, you know, our company, Skyshark, we deal with a lot of, we distribute a lot of pultruded tubes, but one of the big things that we do here is create wrapped carbon tubes, okay? And there's a lot of people that, I guess the difference being between the pultruded carbon and the wrap carbon is that the wrap carbon tubes are, you know, as technology has come forward, but most of it has stayed about the same. In our, you know, they're all made, when we do wrap carbon, people, you have to understand that we're using a pre-preg cloth in different layers that are actually wrapped around a mandrel, okay? This is like tooling is really important for wrap carbon tubes. It's pretty interesting. You know, they're out of a very high-end steel. They have to be straight when they're done. They usually have a notch at the end, which is important, and I'll go into that. But most of the time, a piece of wrapped carbon is done with a pre-preg cloth that there's different weights of it that have the amount of carbon, you know, that's impregnated into the cloth. And, you know, it's the, well, we use different grades of the carbon that get layered, and you see the, you know, 2 wrap, 3 wrap. Well, they're actually taking that pre-preg cloth at a certain weight, cutting it into a pattern that then is layered and stuck together and then wrapped around a mandrel. And then it is actually put into a press that rolls it to get rid of the seam. And then it's put on a machine that will then tighten. Well, that's when you see the cello marks, or the wrapped, that called it wrap tubes. You see the spiraling wound on the tubes, and it runs down, and it will just really fastly zip in under tension. And the amount of, you know, how it's set up, how close the spiral wound is how tight when they're doing the fabrication on the spiral wound, and how they set it, how tight. That's when you see the tubes. You'll see the wrap on the outside of the tube, and the amount of modulus in the carbon then determines the deflection. And of course, you're doing weight. So as the weight goes up, the deflection usually goes up. Then the carbon, the use of the different types of carbon, they're kind of like in a 70, 90, usually a 120 and 150. And as you go up in the modulus and the pre-preg, you get into you know, the heavier tubes, and it changes the deflection and the amount of epoxy that's in it. We're not a big company, so that, you know, we always, when we're doing runs of tubes, you would think that you know, we could make all of the tubes come out exactly the same every time. Well, it doesn't work that way, because we can't buy enough material to do and have maybe, you know, 5,000-10,000 tubes sitting around so that they were all the same material made at the same time. So we always have a little bit of a change from one batch to the next. I can't afford to run more than 500 to 1,000 tubes at a time. So we have variances in like our 2 PTs, 3 PTs, which are tapered tubes versus straight tubes. But to go back to how these are made, once these are wrapped and the cello is put and tightened on these tubes so that they're done, these are on these mandrels. And at that point in time, they take these out, hang them in a rack, and the amount of tooling is like, think about it like baking pies. If you had to make 100 pies and you only had 5 pie pans, you'd have to do a lot of bakes. So if you own more mandrels, you can make 50 at a time, or of the one tube. You put them all in and you bake them, they come out. They actually, at that point, at a certain time, they grab the notch, and they have a puller that has a hydraulic puller that comes out and grabs these tabs, and they have a block that comes up next to the tube, and they pull each one out. Okay, then each one of these tubes is then is cut to length, and the cello comes off, and then they have the finish, which is like the wrapped carbon looking finish on most of the tubes. At that point, they can either be done, or we have a lot of sanded tubes, which are then run through centerless grinders, which will make sure that the outside diameter of the tube is exactly the same from one end to the next, which is interesting, so that you'll still see a little bit of the spiral wound. This is like a P400 tube. So as you know, the OD changes, you know, you can change that by sanding or running them, so you have a continuous roll and spine to the tubes. And then, of course, they actually have an exact weight or not. Well, we try to keep the weights within it. And I have to say that a lot of the straight tubes that are in our industry, and in all kiting, even back in 1987 when I started, most of the high-end sport kites and a lot of the products that were developed in the way of carbon, whether it be pultruded or wrap carbon, came from the archery industry. You know, I mean, they use way more. We didn't create a lot of tubes that were for the kite industry as they grew. We changed things and then changed them around. But still to this day, the technology and where it's going with wrapped carbon tubing is actually come from the archery industry. I mean, we are still making things by hand and by mandrels here. You know, our Skyshark factory, or the people who make our tubes, are living actually Topeka, Kansas, here in the States. And we do small batches. And, you know, we have a lot of different tubes, and in the way of straights. And then we also, but they were derived, and we make our own. And then some of them come from the archery industry as well. I have the ability to buy seconds from the archery industry that, you know, and actually their quality is incredible because of the technology and sophistication and equipment that they have over the ability that we have, because we just can't afford to go there. Okay. And I can show you some of that as it goes. I want to talk a little bit about, so anyway, when the straight tubes, you know, basically what we're doing is in the weight versus on wrapped carbon tubing, and all of the wrapped carbon tubing is internally ferruled. Okay. You want to always, you know, on lighter tubes, we can use, like most of our stuff, that is done in our stuff, they go bigger and smaller, but mostly what we manufacture with the Skyshark tubes has a 244 ID, which is like all of our like P90s, P100s, 200s, 300s, 400s in that segment, and they actually will then correlate to have all of our tapered tubes plug into those tubes. We have some exceptions. Like our 2P, which is a very light tube, actually has a mandrel size, or an inside diameter, of a 1960 or 5 millimeter. And then we have some tubes that you can then use to go from straights to tapered as well. Probably not as many, but most of our products, when you come down to our 0 tube, which is like 8 grams or less, to a 2PT, 3PT, all the way up, you can actually put those tubes either together with themselves, or actually then take one of our straight tubes and plug into any one of those to create framing for kites. Okay. In sport kites, it's a big thing with, you know, you can either use, you know, tapered, or you can do combinations of different things, you know. And it's like, I guess you'd ask, like, okay, why tapered tubes, you know? Well, when we started in this business a long time ago, the only tapered tubes that we really saw back in the day when I first started was in like flexifoil kites, which were, you know, a product of Ray Mary from England. And we used a lot of them because the kind of concept with the kite is that it had a straight tube in the middle, and the outside had tapered tubes that flared, which created an arc, which made that kite fly properly. Well, you know, we here at Skyburner Kites, where we produced a lot of our stuff, I had somebody that was in the archery industry actually provide me with some tapered tubes, and I had no idea whether or not they would work in sport kites. We've been doing Skyburner kites now for over 30 years. And when we first started, we used a lot of pultruded stuff, but a lot of times, as what we were doing, we were breaking a lot of tubes. We didn't have a big wind range with our kites. So, you know, I actually got my hands on some tapered tubes that were from a company that actually had a patent on straight to, you know, parallel to tapered tubes that they actually were using in archery. They shoot the, you know, they fletch the small end, shoot the big end. And I started looking at them, and I figured out how to put a ferrule on them so that they wouldn't break out the big end, figured out how to connect them and put them in the leading edges of a sport kite in the lower spreaders. And it was incredible the kind of performance that we got from a sport kite at that point. Some of the guys that were flying to me, I sent them to me, and they just called me up and said, we can't believe what happened to this kite, you know, on what we can do with it. And at that point, I went to the people who had these, and they started making tubes for us. We kind of redesigned them, and Skyburner Kites was actually the first, you know, company that used, you know, first manufacturing company that used, you know, wrapped tubes in our kites. That was in, like, I think 1992, 91, something like that. We probably weren't the first to use them as an experiment, but we were the first manufacturer to kind of go on, and we created a line of kites with a guy named Glenn Thurber. And we actually at that point called that tube G-Force tubes. Later, that tube, I don't want to get into it, went on to be somebody else's tube, and I started doing other stuff. But since then, we've created, and tapered tubes have kind of been a norm in the sport kite industry, you know, because of the action that they create, where where the strength is needed in the middle of the leading edge and not at the outer tips, as far as in the center parts of the kite. It became very popular, and to this day, some of the finest kites in the world, sport kites wise, are made with tapered tubes. And we also can use them in a lot of other applications in single line kites. I think people have started using them in certain things in that respect too. So that's kind of where we started with the tapered tubes. And then it's evolved, you know. I mean, we've actually used different, at that time, though the diameter of those tubes actually on the IB was a 285. So we're using a ferrule that's a little bit larger. And of course, the bigger the diameter of the tubes, the stiffness, relative stiffness goes up on the tube. As you get diameter, it gets bigger. Now, if you make the wall thinner, you get more spring, but you don't get the durability. Okay, so it's the design aspect of creating tubes, you know, that actually, you know, it's all about the deflection and the amount of rebound depending on what your use is. In sport kites, that's important. You know, I know Spence does a lot of things with some of his stuff, and I know he's tried some of our stuff, and it's really the relationship to how the kite flies and the performance level you get out of it at a weight, you know, and there's things to pick and choose from. But we make ultralight stuff, and it's really based on deflection. And most of the deflection in the archery industry were determined by a weight that hangs at a certain point, you know, on putting a tube across a block and hanging a weight, which then gives you a deflection. And most of the deflections on any of the tapered or straight kites, as the spine, they call it, you know, gets down as the numbers actually get smaller, then they get stiffer. And there's a relative, you know, on a lot of our stuff, I don't actually put all of that on my website, but you can determine it by a lot of the archery information that's out there, because we have a lot of similar tubes. So you can get like at, you know, say a P100 has a deflection of, you know, like a P400. Well, as you go to a P400, it gets down into the 3 series. So there's different ways to determine deflection. And you can also do the same thing with a tapered tube as well. And we make some stuff, you know, and as you want to get something stiffer, you have to use higher modulus carbon if you want to keep the weight down. Like right now, we're making what's called, I'm actually waiting, I'm out of tubes right now. It's called a P400 Pro. Well, a lot of times with our regular P400s, they're a certain strength. And if they have to be stronger than that, we can actually keep the OD the similar, but use a higher modulus carbon. Like on these particular tubes, we can actually keep the weight down to almost what our regular stuff is, but make them very much stronger. Like Joel is using, Joel Schultz, if any of you have seen his kites, he's making a lot of bird series kites right now. He uses a lot of my P400 Pros because he has to, they go into dihedrals, and he has to have a very strong tube to support the wings on his birds. And that's one of the tubes that I actually started making for Joel. As certain manufacturers demand things, we actually produce them sometimes, and then they become a mainstay, and other people start using them and they become popular. So that's one of them. And we also, when we start making like what we call our zero air tube, which is a tapered tube, the weight goes down to like, you know, under 8 grams for a 32.5-inch tube. Is it exactly really stiff? No, but the weight is there depending on what kind of structure you're going to do for an ultralight. Using them full length in some kind of a sport kite is probably not a good idea. But as you make any of the tubes shorter, the deflection goes up. You always have to remember that if you make something shorter, in the span that you're building with, it's going to become stiffer. And actually on our nitro tubes, they actually, the first 9 inches of our tubes are actually the same size. That's when I talked about the wrap carbon tube, the mandrels, in other words, for the first 7 or 8, 9 inches are actually straight, then go to a taper, which means you can take this tube and actually cut it from the big end, and it's strong enough to not have a buildup on the end of it because of the way that the layers of carbon are done in a multi-directional, which is really important to make the strength right. And we can change that and determine deflection. But on this particular tube, you could actually change the strength on a 17.5 gram tube. You can change it when you're using it by cutting off the big end, which would then make it more flexible than cutting off, you know, the small end. You know, in other words, if you leave the smaller diameter end, it's going to be softer. And so you have the ability to change the deflection by what end you cut to a certain extreme, okay? And then, you know, when we were talking about ferrules before, when we're using light tubes, like on our 0 tubes and on PT, 2 PTs, which is like a 9 gram tube, you can actually, instead of ferruling with solid carbon, you can use you know, a pultruded carbon because it's much lighter. And there's no way that when you put 2 together, if you bend them till something breaks, you know, the ferrule's not going to break, the tube will break. So that's not the case when you start going to heavier tubes. You have to use a solid carbon piece, you know, that's usually on most, you know, tubes that you're joining together and leading edges, unless you need a bigger strength factor, you know, are like 3 inches or less. And when you're doing things like in the center of some kites, you get up to 4 to 5 inches on, and it depends on what you're building and how much stress you're putting on the tubes. And the big thing with the ferrules is very important to round the edges, you know, on a sander or something, and then put a mark, put them into the tube. And the other one is that when you're using, we use a lot of CA glue when we're putting ferrules into tubes, okay? So mostly, like on this particular tube, we're usually a CA, and you're putting the CA on this, and you're actually moving this tube around so that you get good layers of glue all the way up to the mark and where you want it to stop. And then you leave it be, wipe off the excess glue, and you've got a ferrule that is in one side of the tube. You know, and if you know, that way we can structurally take things apart to pack them up when it comes to kites, okay? Now, sometimes you can use things in full length. That's the one thing that's different with pultruded tubes. As we're using some of our straight tubes, like any of our P100s, 90s, you can cut and ferrule these tubes anywhere, which means that they are only produced at 32.5 inches. But you can make them longer by just internally ferruling, and they still stay very, very strong. You know, the resilience of the wrap carbon tubes in comparison to pultruded tubes is much greater. You can push the tubes much farther before they break or split. It's amazing how much you can really take one of the wrap tubes. That's the big difference between using wrap tubes and pultruded. There is a difference in price, of course, but they're handmade. But you'd be surprised at, you know, they're not that far off these days. So,
hey, John.
Yes.
We've got a handful of questions in the chat. Would it be useful to kind of go through some of those? I can read them off.
Sure.
Like.
Yeah.
Yeah. Okay. Cool. So the first one is from Gordon Sievers. He asks, how are the CXL tubes different from the Skyshark tubes for quadline use?
Okay, I actually have one of those here. One of the CXL tubes, actually, this is a tube that was derived from the archery industry, okay? And it is a thin wall tube. It has an ID of 8 millimeter, okay? It is actually one of the reasons why you'll see a lot of the wrap carbon tubes that are a thinner wall. They're actually more of a high modulus tube, and they created these tubes. And this is another thing. I mean, the ability for the archery people to make tubes that are so straight, and you know, so the spine being exactly, is because of their technology. And the thinner wall, when they're using them in certain applications, like he might be for a quad kite, is that the rebound is just incredible on how fast they snap back from inputs on the lines for a quad kite. Okay, that is one of the things. Now the downside is that most of the quad kites, being able to buy caps that will actually fit the caps on most of the kites, don't fit. So usually on this kind of a tube, you would take an 8 millimeter tube that's like 1 3/4 inches, glue in 1 inch into the end of it, and leave extended like 7/8 of an inch, which means a regular cap that fits an 8mm that's on like a rev type kite will fit right on the kite. And that's the other thing too. And so it's actually and some of these tubes, as they get bigger, you'll go, well, why would they make archery tubes so big? Like this is one of the bigger tubes that we use. Is called a Jammer 27, which has got a 408 OD. Okay, and it can be ferrule. That's the same way. Well, you'd think, okay, why would they do this? Well, the biggest reason is the OD on this tube. The bigger the tube is when they shoot it, the better chance it has of cutting the center on a target when they're competing. So it actually is. That's one of the reasons why they're making tubes this big. And you'll notice that these tubes actually have this beautiful outside carbony look to them in comparison to our straight tubes gray. Well, basically, excuse me, they actually would make these tubes with an outside layer that's a real pretty, and you'll see this on different tubes, that they'll have different patterns on the outside. That really doesn't change. A lot of times it's a scrim, and it does increase the deflection on the tube a bit, but most of it, it's just looks. I mean, this is like basically, you know, we have tubes that are on my site that are camouflage at one end too. It is basically all they're doing is changing the way this tube looks. It has nothing to do with the internal parts of the tube. It's just, you know, you'll think, oh, you know, but it's actually just looks. It's like putting a fur coat on, wearing different clothes to make a change in the way something looks, basically. All right, any other questions about?
Yeah, we got a handful more. I'll go with the next one. Kevin Coleman asks, I use a 6mm carbon tube for my spines, trimmed and joined with an external aluminum ferrule. I have not been filling the ends of the cut rods, of the cut tubes to go into the ferrule. Should I be filling them? If so, how long should the plug be?
No, actually, if he's not breaking any of the if the 6mm is not, if he doesn't have any breakage at the ferrule, or he's not splitting any of the tubes, then I don't see any reason why to plug them. Usually it's under the circumstances of trying something and you go, geez, man, I've been flying this and I've had to replace the spine and it breaks at the ferrule like several times. And you're like, well, you know, that's when you would use a plug, and you find either, most of the time, carbon or even fiberglass works because it has some give on the wall, and you want to find something that fits the inside diameter of that 6mm, which is not easy to find all the time. And then you probably, you know, want to make it so that the plug goes at least an inch or two past the ferrule, because that's where the stress is when the tube is bending at the ferrule. You know, a lot of the, most of the fiberglass, like in less expensive kites, they're almost using 6mm fiberglass, and they're always putting a 6-inch plug where it plugs into the center T, because when you fly it in big wind and if they break, they know from experience that's how you can increase the wind range on a kite.
Cool. Okay. So we have another quick question from Mickey. I will soon have access to a bunch of used tent poles of various types from friends with lots of incomplete camping tents. Anything I should be wary of using? Anything useful I should know?
Well, most of the, we've actually produced a lot of stuff for tents, and most of them, in fact, back in the day when we first started, it was almost impossible to find good ferrules for, like, say, 5.5 carbon or 2200s, which they don't make anymore. And we used a lot of ferrules that were actually made from Easton aluminum from archery arrows. They're very light, but if you put them under a lot of pressure, they would break, you know. But we would then put another, like if you made a 2.5-inch ferrule, you could actually take another ferrule that fit over that aluminum and double it and put it in the middle, and it would stop breaking in the middle on our kites. So when we made ferrules, they were actually, you know, 2.5 inches with an inch piece glued in the middle of it when we first started on all of our Skyburner kites, because, you know, we would actually under stress break stuff. But as far as camping gear goes, most of the camping, they're usually aluminum that has bungee running through the middle of it so that they have ferrules in them so they slide together and you can wrap them up and put them in a tent. You know, sometimes you can use that stuff in kites. It's a little bit heavy, most of it. But yeah, you know, anything that works that creates structure, if it's not too heavy, will work in an application for creating something.
Cool. Next bit we have is kind of more of a comment. Ron Burkout mentions he would love to see some 5mm wrapped straight carbon tubes in the future. I don't know if you have any thoughts on that. Okay,
well, this is a really interesting, you know, the problem with doing, you know, that kind of wrap carbon is, of course, what we talked about is tooling, okay? So think about how small the inside diameter of a 5mm tube would have to be. Like if you take a 5mm now, which I can take out of my wrap. And the other thing that we should have talked about earlier too is a micrometer. A lot of people call up and they say, hey, I want to replace you know, I need a tube for a kite that broke. And I said, well, what size is it? I don't know. I said, what kind of kite? I don't know. Well, you know how many different ones there are? Well, you know, most of the time we can determine what that tube is by using a micrometer like this. I like the digital ones. They're real easy to use, and you can use them in millimeters or you can use them in inches, okay? And like I have a 5mm tube here, which is actually, you know, runs from about 194, which these are tubes that come from Avia and or from Goodwin's, and that's a 5mm tube, okay, which is relatively small, okay? Well, you look at the inside diameter and it's a 0.124. So the wall thickness then is determined. Well, if we were to do this with a wrapped tube and you think about how small we would have to and how much tooling we would have to have and able to make the tooling to make a 5mm tube that straight and wrap it and still use it is extremely difficult. And it'd be very expensive as well. Now they do make, right now the archery industry is making a tube which I have access to every once in a while, which is nanotechnology. And actually it's a tube that actually is slightly bigger than a 5mm, which is, I actually have it in my bin over here, and it's actually very stiff at a 32.5-inch length. It weighs about 16 grams. And actually, this is the smallest wrap tube I have ever seen. It's right here. You can look at this, and it has an OD of actually 0.202, and it's incredibly strong. Okay. But a lot of times I've found that when we have a wrapped tube and what to do this and then to ferrule it, you can't, if you internally ferrule it, it would be very difficult to find a pin that would be strong enough that when you bent the two of them, the pin wouldn't bend unless it was made out of titanium or something, or then you're back to using external ferrules. So what is the advantage of having a wrapped tube that's 5mm? Is it that it weighs less? Well, this is actually nanotechnology at its best, okay? And this is an archery tube that actually, when they sell them, usually sells for about $200 a dozen, okay? And it actually, one of the reasons why I don't like to mess with these tubes too much is that they're the toxicity. In other words, nanotechnology to cut this is like really scary. My guy that makes my carbon won't even work with it because of the fibers are so small with nanotechnology. The chances and the safety, you know, and anytime that you're also cutting this carbon, you should be wearing a mask and or have a vacuum system or doing it outside, and you want to use a wheel that actually is turning at like, you know, at least 5,000 RPMs with a really nice narrow, and it makes a really nice cut. I mean, you can cut carbon fiber, you know, other ways if you sand it and you're really careful with it. But most of the time we're using a fiber wheel that's very narrow at a high speed to cut these tubes that are really nice, even cut. But I guess I'd had these tubes and I figured, okay, this is close to a 5mm. What could I use it for? What is the advantage? You know, yes, it's a little bit stiffer and stronger than a 5mm pultruded tube, but is it worth what it takes to manufacture it and the usage of it, you know? I mean, I've had these, and I just haven't seen the use and what we could do them. So that's my question, I guess. Is it something you want because of weight, or is it you know, when, you know, it depends on is there such an advantage of difference in weight and I guess durability of it at using a smaller diameter tube. That's the best I can do.
And I have to wait another 10 years maybe. Thank you very much for the explanation.
So,
well,
All right, cool.
For something that small, wouldn't a pultruded tube be at risk of spaghettiing? You know, it's so thin that a pultruded tube might crush, where a wound tube that size might not.
yes, now that is true. That would be the one advantage that this tube would have, is that it would probably hold up, you know, much better under stress in that, you know, in that aspect. But at that point in time, okay, so you can take the same tube at the same weight and use a wrap carbon tube that had the same deflection, okay? So that you're, you know, it depends on, okay, so it's bigger in diameter on whatever single line or whatever kite you're using, so you have to have a bigger pocket, or you have to accommodate a bigger diameter tube that actually is weighing less and doing more structurally. So why would you do that? You know, that's the whole thing. That's why I said, you know, the other tubes that I have that weigh, you know, and the other one is that you can take a pultruded tube at a 5mm at 32.5 and weigh it, and I'm probably thinking it probably weighs 17, you know, to 18 grams. I'd have to look at that. Okay, well, there's, you know, you can use one of my, you know, at a 5mm, you can go to my P400 tube that weighs 13 grams. It is 3 times as strong and durable as that 5mm tube, and you can internally ferrule it. So why? You know, it may be a cost factor, you know, if you're you know, doing lots of kites, that would be the one thing, you know, on how it's done. So that's the other one too. Like, I know I was actually looking at I have one of Jon's kites that I was looking at where he uses a pultruded tube down the middle of it, and I love how he used 1/8 inch, you know, pultruded tube rather than used a solid tube in the back of his kite. And I'll show you. And I have to say, Jon makes some of the finest kites, and I am so lucky that I would actually have one of his kites, okay, which is just gorgeous. But the way that he's done these outside and how this is curved to create tension on the pockets on this, which can be variably then tightened up to create this tension, is fabulous. Now, he uses a tube, which is a lot lighter, and it's actually got more deflection. If he was, you know, to use a solid tube, he would probably have to go up into a lot bigger diameter, and it would, you know, and to bend it would put a lot more pressure on pockets. So there's got to be a reason for flight characteristics that he decided to use a tube versus a solid on this application, okay? And this is just an incredibly great flying kite, as well as the quality of workmanship is just unbelievable. So that's a you know, that's a use of, and it's got a pultruded carbon down the center, which if he wanted to make it lighter and he joined it in the middle with an external ferrule, he could actually be using a wrap tube that would probably have about the same deflection. I mean, all kites, depending on the designer, you know, I mean, sometimes you can reframe a kite that was done in fiberglass, and it actually, you can make it not fly as good. It might fly lighter, but if the balance changes, what's the good? You know, it really has to depend on, then you might have to redesign the kite to make it fly right. You know, there's always the design aspects of what works best in the way that the weight is distributed through with the carbon and the structural integrity of the framing. So that has a lot to do with it. You know, we're using a lot of different, you know, we use that longer length stuff. Like we started doing some things with sailboat mass. So when we talked about our nitro tubes, we actually have some 44-inch tubes that are great for kite building, but they're also really fine for the remote control sailboat industry, you know, but they can actually then be plugged into using ferrules. They can, you know, you can go to a straight. We also make a straight that's our longest at 44. A lot of people will ask us, well, why don't you have bigger diameter tubes and longer lengths? Okay, well, the big thing that happens when you're doing wrapped carbon tubes is that, of course, the tooling is expensive. And then the other one is when you start making stuff that long, it's not that easy to actually get the carbon off the mandrels. Here's an example right here. I've got a mandrel right here with a tube on it that's never going to come off, and the end of it's cracked right off. And what happened is they could not get this carbon off this mandrel and actually broke the end of the mandrel off. So there's a lot of things that come into play when you're doing wrapped carbon tubes, you know. But it's nice to, you know, like that's the longest tube we make is 44 inches. And we do some other, we do 40-inch stuff, and a lot of our stuff is based on 32.5 inches, just because it's been a standard in the industry for a really long time in our tapered tubes. And it depends on the application. I was going to start is some, you know, like we use tapered tubes also in, excuse me, come off camera for a minute, like there's a lot of people that are doing 8-sided, 6- and 8-sided kites, and I've produced some kites that we use a spoke in the middle like this, and then they go out to a taper, which actually can just, you know, because the tips are softer, makes an incredible, you know, I'm sitting here with the skin that goes to this, that actually, when this is actually put in the middle of a kite and it's in all of the pockets out at the end, it actually pops like an umbrella if it's done properly, and the tips are soft, and it just, the way the wind goes over a flat type kite, it just, you know, it's the aspect of how it works. But the tapered tubes, I think if I did this and I tried it with a straight tube, the kite didn't fly near as well as with a tapered tube. And then you're using, you know, a spoke in the middle of it so that you don't have any tubes crossing each other, different weights, and you can pack up the kite tune really small by just unplugging all of these and plugging them in and out. That's, you know, so there's a difference for a single line kite with doing a lot of, and this particular tube has a steep taper, you know, and we do some other tubes that have stiff tapers as well. I had talked earlier about having we make a 2P, which is our smallest, which has got an ID of 5 millimeter, okay, which is a pretty tough tube, and it only weighs like 9.5 grams. But then you can take a taper tube, which goes down to almost an 1/8 inch taper at the top, and we produce. I don't do a lot of these. This particular tube, we actually have mandrels that are this small that were used for other things, but as they get at the end, they get extremely stiff at the outer tip. We designed and actually made these tubes for the Synergy Deca kites that were used in the Circle A. You know, all of the kites that they were flying with the Cirque were actually framed in Skyshark tubes with our 2Ps and this particular tapered tube. So we do some different applications in that respect as well. I'm trying to think what else was. Any other questions?
Yeah, we still have some in here. Andre asked, as the diameter increases, does the stiffness increase linearly, exponentially, logarithmically? You have any insights on that?
Yes, you know, well, that's it. As the diameter of the tubes, you know, depending on the wall thickness and the inside diameter, almost always for the same weight. In other words, if you took, like, for example, we've got like this big tube that's a 408. If I take, and it weighs about 17, 18 grams, so this is very stiff for its weight, but it's got a thinner wall. Well, you take like one of our tubes that's like, say, the same weight, which is a P400, okay, well, you know, you've got probably a different rebound because of the bigger ID and the thinner wall. But I have to tell you, if I pushed this bigger diameter tube to a point to where it broke, the P300, because of its wall being a 244 and the OD of it in the same weight, you could push this so much farther before it broke than the thin wall tube. So there's a give and take with using bigger OD things, you know, unless they're for big kites that are you're doing, and then they get heavier. And of course, if you're taking a bigger diameter tube with a heavier wall, well, then it's going to get even stiffer. Like I've got, like, look at the fiberglass. Like this is a pretty big fiberglass tube that we're using on big cross spreaders, like on in Premier's kites on their big deltas. You know, whenever you do big deltas, the big thing that breaks always when you push wind too hard on a big delta is the cross spreader. You know, and usually they're not in one length because you can't pack them up. If they're that big, you got to have a ferrule in the middle so something goes. So they basically then go to a piece of fiberglass, which is like, look at the stiffness of this fiberglass, which is probably has got an OD of, okay, this is a 10 millimeter tube. But look at the wall on this particular one is huge. So the inside diameter is like a 5.5 millimeter. So because of the wall and how big it is, it's incredibly stiff and it's tough as hell. You know, I mean, this thing's a monster. But that's what it takes. You know, that's kind of the way it works. Wall thickness, you know, versus OD, and then deflection in the material. Now, if this was made out of carbon with this thick a wall, you wouldn't be able to even bend it. Okay, so that's another thing. So yeah, we were talking about, you know, hey, and the other thing I want to talk a little bit about, I think that you'd be interested in, if there's not a lot more questions, is tools. I build a lot of kites. Okay, and I try to make things easier using different tools. You know, I don't know, we use a lot of you know, you always are using stops and on certain certain materials. End caps are usually a big user of stuff, and I actually have. I thought I had. Hold on, it's just a minute here. So a lot of the end caps come in different sizes, and it's like, okay, you want to make donuts, you want to put stops. You can either use these C-clips that break loose all the time, or you have some place to stop on your kites. I have these really nice cutters that I don't know if you can still buy these somewhere, but I've had these for so long that you can actually have a stop in here and make a thing, and you can use them and make an exact donut that's exactly the width that you want it. Okay, and I can make fat ones and whatever I set up and I determine with my tool here, which is something I think that's really important. And then how many times do you have an APA connector or some kind of connector that you can't get on a tube because you want it to be tight? Here's another tool that I think is one of the best things you could ever come up with. I bought a pair of snap ring pliers and ground down the ends so it looks like two flat-headed screwdrivers that come together. These tools have been in my arsenal, and they are so beat up that if I lost these, I'd be in a lot of trouble. But anytime that you want to put like an APA and you put these on, and if you spread these before you get ready to put them on, people say, well, how do you get that connector? It'll never fit on there. How do you push it? Well, if you open this up on the opening before you stick this onto you know, one of these tubes, it actually is all the difference in the world of being able to move this to where you want it. And if you didn't do that, it's like you either have to heat them up or come up with something. I also sometimes have a can of silicone that I'll have a spray on the bench and put a dab on it when I'm building kites to move things around, because I'm building, you know, a lot of, you know, different sport kites repetitiously, you know, from the skins and making stuff on them. So some of the parts that are there is like the APAs, you know, from those, and then TAPAs, which is a smaller version of those. Lots of different kinds of center tees for building, which I think are really important. We do like what's a Beeman tee, man, I sell these all over the world. and they can be adapted, and then you can take the same tee and put a ferrule in the middle of it to create a center tee, or a three-way to go different directions. There's been the people that make the solid connectors like this. Those are more, in Europe, they're easier to get because they were made by Excel. But yeah, that's, we try to keep a lot of parts in stock, for people that are building kites, man. I'm shipping stuff to over 20 some different countries all the time. From being in this business, it's, I have to say, I still enjoy what I do. Like I said, this is what I do for a living. I'm sitting here on Sunday in my Kites and Fun Things, and I've had a brick and mortar store for 32 years, okay? So, and I've been manufacturing carbon probably for 28, yeah, it's going on 28 years now too. So, we try to, and I'm always here to answer questions. And we try to keep what everybody needs to build kites, whether it's for themselves or you're a manufacturer making your living from doing kites. I think it would be nice just to be a hobbyist sometimes. I've been working with my wife, Mary Ann, for 32 years, but we love what we do. We're open to the public, and we sell, all kinds of kite products and finished kites and materials for other people to make kites. We're a big distributor of Icarex sailcloth as well. Plus all the Skyshark line. We're a distributor for Goodwins, who does a lot of all their Pultruded tubes and fittings, and then whatever else. To protect my business in building kites, I've always found that if you don't have something in stock, one thing can keep you from building a kite. If you can't get it. And it's like, hey, right now we're in trouble, and they redid the molds, and you can't get an APA, 250 or 200 standoff holder. And it's like almost got me shut down building kites. I'm having to use inferior products to make it work, and I hate it. So there's things that come up, I had talked about, we were doing hubs. There's different, things that they have from wind spinners that you can turn into things to build kites with. Big hubs. Like, I love these things that were always made for the big windmills, but you can sure turn these into nice things to build things. And I know the people that are doing moldings, these small ones that have created these things where you have the ability to make stuff like this in the center of the kites, so you can do these beautiful box kites and this kind of stuff. So it really depends on the application and the bend on stuff. That's why I like building a lot of stuff out of wrap tubes. The amount of bend that you can put in certain things to create different projects are really amazing. And then it's just determining whether or not the amount of flex that you need, like for doing wingtips on kites like this, like John was using on his, on how to bend, and whether fiberglass is a good idea because it bends or is softer than carbon. So there's a lot of different applications, for making kites, whether it be single line kites, dual line kites. I know we have a lot of people. I have in our area a Bob who makes fighter kites that just uses in flat carbons as well to make spines for fighter kites that are just, and he actually has ways of trimming them to create the bow that you need at the top. That's just amazing, so materials can really advance on the kind of kites that we can create these days, I think. So,
John, can you hear me?
Yeah.
I have two questions. One is, I hear some people, they use thread wrapping around the end of their kite, or internal reinforcements if they're using an external ferrule. What do you think about using thread wraps to reinforce the ends? No,
and I have actually seen this a lot, you know, some of the guys that are using this that I saw early on are guys that are doing sailboat masts and things like this, and they do. I've seen some other ones too where they'll take really good thread wrap around the outside of a pultruded tube, you know, and then they'll use epoxy to almost create an external ferrule, especially on if you're using a pultruded tube and you have to drill a hole in it or something, you know, for some kind of a certain deal. And because just, you know, if you ever try to drill a small hole in a pultruded tube or even large, it's not easy to do without it splitting out. So you have to reinforce it somehow. So yeah, that's, you know, that's a very creative way to strengthen a tube, is by doing that kind of you know, a wrap on the outside of a tube, you know. Yeah, there's a lot of things, and we do a lot of stuff, like in a lot of our stuff too, we do a lot of, like with arrow nocks too, we actually have external, you know, they're all 6 millimeters, so you can take a knock and have what we call it's a knock with a plug, which then goes inside and can be glued or taken in and out of a wrap carbon tube, or they actually, the ones from the archery industry are used, and they're just push-in knocks that go into the end on a 24 are the same way. So it's just application, you know. Some of the new, the new fittings with the screw backs that are attaching these kind of things to sport kites or single line kites are incredible. This is a new, pretty much comes from a company out of China, and they actually have a screw back so that you can determine on microcarbon and plug anything into them with a cap, and then actually then, you know, have a small hole in a sail and pull these down to any kind of sail or Dacron reinforcement, which is great because they have all different sizes. I love how they've contoured. This is one of the newer ones that I've seen. I know there's different people making these, but this is one of the latest ones that I've seen. And then I use them, you know, there's no reason, like on my box kite that I've got here, that I actually used in the middle of mine and actually whacked them off and drilled a hole in them and put a circular snap ring in them so they can use it for a pull point on something, you know. There's just really inventive stuff. And then a lot of the end caps that we use, the FSD, the Germans, which Jens has created a lot of the FSD end caps that actually have a hole in them with a slot so that you can use these with an eyelet that go on the tips on pulling things tight on stuff, which are incredible. Some of the stuff I love, you know. The other thing with ferrules, we do a lot of, like, I've tried, we, you know, it was hard to create them or to find them, was 1/8 inch, you know, stainless steel ferrules, because when you use 1/8 inch, if you use brass, under most circumstances, if you use one at any length and it's brass, you'll look and say, wow, it's bent. You know, under most, it doesn't take much load to bend one, and then it doesn't come back. You know, and then you can push them into a T like this and create a T for an 1/8 inch, you know, whatever you're making, you know, in a lot of circumstances, like we do a lot of glider kites, which uses 1/8 inch, you know, pultruded tubes. These are fabulous for that kind of stuff. You know, the parts and connectors, you know, are really important, you know, when it comes to having the right thing to, you know, I mean, you can make things with tubing and things that work just as well, but a lot of the molded parts, and as the kite industry has moved, you know, we're, you know, I have to say that we're kiting, unfortunately, I've seen so much, and I do so much international business, we're kind of like, through technology, we've lost a lot of young people that are in this sport, okay, or are building kites. So we're having a decline in the industry, you know, unfortunately. Because of COVID, we've had a lot more people doing outside, and we're having a little bit of a rebound, which is, you know, good after bad, but it's like, it's forced people to be back outside. And, you know, I think people also are figuring out that it's not the greatest thing that their kids are playing video games and not going out of the house, okay? So it's like they're fighting back. But we're seeing this, in other words, what I'm saying is, as the industry declines, it gets harder and harder to find the things that we've always took for granted as building materials for kites, you know? As one manufacturer that always made a certain thing runs out of something, it's like, okay, is it feasible or is it worthwhile financially to keep doing this product? And you see less and less things that are available anymore. And sometimes they just, you know, they run out and you can't buy them anymore. You know, it's like, we're starting to see that with some of the distributors of Pultruded Carbon. You know, we see sizes, like no longer can you buy or find an 1800 Pultruded tube in America right now. You can't find a 2200, which is a 5.5. I have 5.5 because it's the same thing from Europe, and I have those. But it's like, but if you were building with them before and you need to replace something, you're kind of out of luck on a lot of parts. There's a lot of times where it's more and more I have to turn people down. You know, I had a guy come in here the other day that had an old North Shore that had 260, the old aluminum with carbon over the outside of it, a Spar. You can't find it anymore. They're gone. You know, I actually found a new archery tube that had a 260 that was wrapped that had the same stiffness that he could replace it with. You know, so it's like, yeah, we're having to make do because that's the kind of thing that's happening. And the decline of kite stores, you know, around the world, you know, everywhere. It's affected that kind of thing, you know. So, I mean, I think the big worry right now is that we lose sponsorship for big kiting events, you know, and we don't have the gatherings that we had before. It's a scary thing if you love kites, okay? Yeah, we're seeing a lot of that. You know, I don't want to go into that part of it, but it's like my life is kites 6 days a week for the last 32 years. There's not too many people in this industry I don't know, okay? And, you know, I love what I do, but I don't like what I see all the time. We've seen a lot of growth in Asia. The Chinese people have really embraced a lot of kiting and new stuff. I actually am fortunate enough and still am shipping carbon to China. So I can compete, but it's nice to see that, you know, in emerging cultures that we're still seeing, you know, some movement in the right direction in kiting, you know. But it's always nice to have hobbyists, you know, like yourselves that, you know, are always trying to create something new in the way of it being artistic or just the love of watching something fly, man, and being able to do it. I'm real big. We're inland, so my big thing has always been I create a lot of things that are very light, you know, ultralight, because I like to fly all the time, and we're inland. And, you know, I could never wait. You know, when I first started, all of the big sport kites and stuff were fiberglass. And it was like we had to, you know, we didn't come to the beach where we had good wind all the time. So it's like we had to wait for the weather to be really something to be able to go and fly a kite, you know. And I got tired of that and started creating, you know, a lot lighter weight type materials, which is into the carbon stuff, and trying to produce stuff that are, you know, the wind range. And that's the whole thing. It's like a lot of, that's another thing that I didn't talk about is people call up and say, well, I'm building something and it's like, I want to frame it. Well, my big question to you is like, what do you want the wind range to be? You know, do you want something you're going to fly light? Do you want it to be heavy? Now you do have a lot of, with the new stuff, you can create stuff actually that's really light, and then actually have a whole, you can actually slide Pultruded Carbon right inside 2400s right inside of our wrap carbon tubes for a day where it's blowing 10 miles an hour more than it was you know, when you built it and what you wanted it to still fly it. So you can vary the wind range on things by loading carbon, you know, changing, you know, the frames and certain things, you know, some, you know, it depends on what it is. Some things are built to be what they are is what they are, and they're for a wind condition, and you have kites for high wind, intermediate and low wind stuff. So I really excel at making stuff that's light, you know. That's always been my favorite, you know, kind of kite building. But yeah, I'm just not from an area. Whenever I go to the beach and I have to deal with 15 to 20 mile an hour winds, like you guys get out on the West Coast, it's like a whole different thing. I'm out of my element. So, but I do get to travel, which I miss dearly right now, to go to festivals like Cervia and places in Europe where you just see so many, you know, great wind and just the amount of artists that create just beautiful, beautiful kites, you know. So, and have just great imagination. So, you know, we're always here to be trying to innovate with structural parts for people that are building kites. So,
so John, I wonder if I can pause you real quick. We have about 15 minutes left, and I know there's still kind of a handful of topics in the chat there. I wonder if maybe, is there some good contact information that people can get from you to ask follow-up questions? And then I might jump over to the next session and get that one started. But I just want to make sure people have an avenue to get their questions answered.
Oh, well, yeah, you know, like, you know, we're here all the time. So, you know, you can always go to, you know, we try to put as much information as we can on, you know, our websites, which is, you know, Skyshark, you know, skyshark.com, you know, the Skyburner site. I've tried to, you know, have all the information about the tubes that we have available. And of course, on Kites and Fun Things, you know, the amount of parts and stuff that we list, we're always adding stuff. But there's a lot of stuff I can't keep up with, you know, as times change. So there's always more. I mean, I've got 32 years of stuff around this shop. So it's like I can't put all of it. But I can usually come up with what somebody needs. But I can always be reached at our main email address, okay, which is on the Skyburner site, which is jtnm@skyburner.com. Okay, and I'm always here to answer questions, you know, through email.
Awesome, thanks, John. And yeah, I'm gonna jump over to the next session to get that one started. This will keep going until the last person leaves. So if anyone wants to stick around and jump in on mic to ask John some more questions, then feel free to do that. And I'm gonna get the next session started, but no one else will be able to join, but I won't be able to kick anyone who's annoying either. So yeah. Yeah.
Hey,
so there you go.
Hey, John.
You know, hey, thanks a lot. You know,
Thanks, Vince.
Yeah, you know, it's like thanks for the opportunity, and you know, I'm here always to pass on good info about people that love to make kites.
Hey, John, can I ask you something?
Sure.
Why did you stop clear coating your black diamond tubes?
That's a good question, but one of the main reasons that we did is that the paint that you have to use to coat these tubes, okay, is very expensive. It's also very difficult to ship around the country because it's a thinner, you know, I mean, it's a paint product, so it actually has to get shipped different. And I guess as the industry declined on high-end stuff, that we felt, you know, one of the reasons why we were doing it was to make the kites, the tubes look pretty, but mostly the reason behind sanding a lot of our tapered tubes has to do with the amount of tricks and things that people are doing with sport kites, okay? So when you leave the ribbing on, you know, the filament on the wound tubes that are usually on lower spreaders, this stuff is like sandpaper, okay? I have guys that you can wear out. You can wear out a bridle so fast, okay, that it's amazing. So the basic thing and why we still carry sanded tubes versus regular tubes is because they're usually used for lower spreaders, or they could be easier to build with because you're sliding stuff around. So basically, we just said, okay, is it worth the expense of keeping these in stock? I have so many tubes, and to do one more at the price and to paint them, and the expense of it, is it really worth it? You know, because basically the next step after we sand them is actually just putting the paint on them, okay? And the other one is that they have to be printed before you put the paint on, okay? That means that my manufacturer, or the guy who's doing my tubes at the factory, actually has to print my tubes there and then paint them. He doesn't have any, and the equipment he was using to print the tubes was not, it wasn't viable anymore, okay? So that was one of the reasons to do it. So we figured, hell, at this point, instead of making them look really beautiful on these tubes, which I loved doing for a long time, we just said, we'll just offer them sanded, okay? Now, I will tell you that there's a secret that I've been doing with my stuff, is there's some materials out there right now where I actually, on my stuff that's sanded, when I send out my high-end kites now, there are some products that they have made for polishing carbon. that they're using on high-end exotic cars, okay? And it's actually made by Meguiar's. I have some around here, and you can actually take and buff one of these tubes out, take a cotton undershirt and buff it, and there is no way that that will come off on any of your material, and you ought to see the difference in what they look like. They don't look as good as the painted ones do, but I have to tell you, the improvement from, you know, polishing them by hand before you use them versus the painted is significant.
Yep. My main goal is to reduce wear on the bridle.
Yeah, well, you know, I kind of think that, you know, the difference between them being just sanded and not painted, you know, I mean, are you still seeing more wear or, you know, are you still seeing more wear between when they were painted and just being smooth?
No, I don't know because I haven't bought any since I couldn't get the.
Well, we're still making the same tube, and they're polished and they're smooth, and you know that's just our line. You can buy any of our most of our, you know, 3 PTs, 5 PTs, 7 PTs, and a lot of the nitro tubes are all sanded, you know, and especially for lower. So if you look at our stuff and you're going to use them in lower spreaders, buy the sanded tubes. You know, we kind of those are kind of like the Black Diamond series of our tubes, which are sanded, and
Okay.
you know that's the solution to it.
Thank you.
So John,
I have a quick question.
Sure.
Oh, sorry. Go ahead, Lindsay. Go ahead.
So a couple people had questions about cutting the carbon, and I know for us, we have a 40 thousandths kerf diamond blade that we use for cutting our fiberglass and stuff in the shop, and it's a 10-inch blade, but it was also $200. So
yeah,
but it's amazing. I mean, a 40 thousandths kerf blade, I had to make stiffeners out of old saw blades to keep it from wobbling around, but it's awesome. And people are talking about, you know, Harbor Freight little chop saws. You could use an abrasive wheel if you can find a thin enough one. That's the thing. And the other thing is that abrasive wheels, though, I mean, you're melting the resins. You're melting through it. You're cutting, but you're also melting the resins.
Yeah, there's you know what, that is the thing. I have found some alternative blades for my 4-inch Easton diamond cut, you know, that I have for archery.
Yeah. That was the other thing I was going to suggest is a aeroshaft saw.
You do, and that's what I'm using on mine. And the blades, though, you have to buy them special 4-inch, and they're very narrow. And the other thing is, if you make a mistake with, you know, moving carbon in and out, man, you can blow up blades really easy, okay? But they're the best. You know, I cut a lot of carbon, so I go through a lot of those blades. I've went to a little bit thicker one lately that I found that's a little bit more durable than some of the thinner ones that I'd had. In fact, I'm out of them and I need to buy some more of them. But yeah, it's really important, you know. And the other one is, you know, I'm cutting in my basement all the time, so I have a very extravagant, you know, vacuum system that goes to my saw, you know, that actually goes into you know, into a vacuum that's in a big 55-gallon trash can. But I also have another. It's kind of like they're hard to come by. They look like an hourglass. So all the carbon, when it comes through and goes there, it falls to the bottom.
Right.
So Lindsay, well, John, I was going to ask you about the Ohashi that's behind you and what the spreaders, those not the spine, but the spreaders, and what I couldn't remember if they were carbon or,
you know, yeah,
fiberglass.
On John's kite, he's using 1/8-inch pultruded carbon that's tube.
Okay. And then
John, I have to leave in about a second because I'm teaching the next class. But the next class is about tools and tidbits and stuff. And while you were talking about cutting, I don't know if you'll be on that class, but I'm dying to harvest this information from you. When you don't have big electric tools available, how do you cut your tubes? If you're out on the beach, you have to cut something, or your saw is on the fritz.
You know what? I usually have a fine tooth blade that I use that's in my bag. but I also have some knives that have serrated, and if you're, you know, moving a tube on a surface, you can usually cut it and then sand it, you know, when you're on the field. You know, it's not as easy, but it can be done. You just have to be careful. A lot of times you can tape it as well, okay?
So you
All
just
right.
like a bread knife.
Yeah. Yeah, yeah, almost like it's like, yeah, or a file. A file works good too. You have to rotate and use a file, but you have to keep it in a nice line to what you're cutting off straight. So, all right. Any other questions?
John, thanks for doing this, and thanks for taking care of us people that try to do workshops.
Hey, man, anytime, man. I'm really willing to work with any of you guys. Thank you very much. I've got something I got to do as well. Thank you.
All right. Hey, thanks, John. And
All
by
right.
the way, when you're wrapping string around in you know, to reinforce that ferrule, in nautical term, it's called French whipping.
Oh, okay.
Yeah.
Good to know.
Yeah.
All right.
All right.
All right. Have a good day, you guys.
Bye, John.
All righty. Bye-bye.